welcome back once more, and in this video we are continuing with taking a look at textures. How are textures imported, what kind of rules should they adhere to, for example size restrictions, things happening behind the scenes, for example texture streaming, mipmaps, and so on. Right, so first of all, textures are compressed on import. They're always compressed. Compression differs per platform. BC or DXTC, as more commonly known and by its older name, is used for PC. So every single, different types of hardware, they all have their own texture compressions. Unreal handles most of this behind the scenes. So usually you don't have to configure it, by yourself. You don't have to convert textures. It will happen by itself. Since you usually work on a Windows-based platform, therefore BC or DXTC for PC and for Windows is the standard format. Now, DXTC, or DXT, as also known, stands for DirectX Texture Compression, or BC stands for Block Compression. They're all the same thing. Block compression indicates that it's compressing things by creating blocks. So it creates blocks of pixels, and based on the colors it finds within those blocks of pixels, it will change some of the colors, simplify it, and then compress it block per block. It's block compression. Block compression has many more different compression settings that are not exposed by Unreal Engine 4 by default. Okay, so you can actually do quite a lot with it. Unreal Engine 4 uses a simplified version of this. And it should also be noted that normal maps are a special case scenario. So normal maps use a special compression setting which only saves red and green and does a couple of additional things. Look, a normal map normally uses a red, green, and blue channel, right? All three colors to determine the different axes that it could be, how it responds to lighting. But you can actually calculate the blue channel by looking at red and green. So we remove the blue channel, the blue color, and we recalculate blue on the fly using the information we extrapolate from red and green. So for that reason, normal maps are a special case scenario with special compression needs. Now the compression is similar to JPEG in a sense. In the same sense that if you would zoom in on it and it's heavily compressed, you're going to start seeing these kind of blocky structures in it. It's similar to that. BC3 or DXTC5 is used for textures with alpha. BC1 or DXTC1 is used for textures without alpha. So those are the most common types. DXTC1 or 5, or if you wish BC3 or BC1. That's what you're going to use most of the time. So anytime a texture has no alpha, it becomes BC1. Anytime it has alpha, it becomes BC3. There are a couple of plugins for example, Photoshop that allow you to check this, to convert or preview the compression of textures. So here's just an example picture from the project I'm using. It's very low resolution, so we're all the way zoomed in. And one of the tools you can use is the Intel Texture Works. You can download this. It's a free plugin. And this will allow you to save DDS files. DDS are the texture format used for BC3 or DXTC. I believe the DDS stands for Direct Draw Surface, if I'm remembering correctly. And when you save it as a DDS, you can pick what it should be. So you can see the different compression types here. We're going to ignore that for a second. Just click Preview. And if you click Preview, we can actually see what it's doing. So on the left, we see the original. On the right, we see the compressed result. You can see that if we're running BC1, this is how it would look. In fact, you can change to none, so it's uncompressed, and you can see the difference. So it does lead to some compression. I mean, it's visible, the compression, but it's not that bad. Size-wise, you can see that if you run no compression, it's 144 kilobyte, whereas with BC1, you're at 18 kilobytes, so it's quite a large difference. You can see that BC7 offers the best quality, because it leads to almost no difference in quality whatsoever, but the size is 36 kilobyte down from 144. Now you can use these kind of tools in Photoshop or similar to preview it, to look at the settings available, to look at the options you have, but you can't use this to import it into Unreal. Because as mentioned, the moment you import a texture into Unreal, if you just hit import and you import an image, it automatically compresses the moment it imports. That's why when you click on a texture, and you look in the properties here, it's going to say resource size is 683 kilobyte for this texture you see right here. This is the compressed result. In fact, it says here format DXTC1, right? because this has no alpha, has alpha channel false, so it becomes 1, and that gives it 683 kilobyte. There are compression settings in here. Here it says compression settings, and it's set to default, which you can see it says DXC 1 or 5 or BC 1 or 3 on DirectX 11. You can see the different settings you have. You got BC 7 here, which gives the best possible quality. You also have uncompressed ones. The one that say RGB 8 or similar are usually uncompressed, so be careful with this. The names here are not the best, I personally think, so be careful and properly read up on what this all means. Grayscale, for example, is often much bigger in size than a compressed texture. Grayscale is basically uncompressed, so it might sound as if it's better, but it's not. So properly read into it. If you want to uncompress it, you could, for example, take vector displacement map, which basically means uncompressed. You see, if you do that, the format now changes back to RGB 8A, and the size is now 5.5 megabyte, almost. It's more than 5 megabyte big, so that's the difference between compression or not. You can look at normal maps, and if you look at a normal map here, you can see this is running, it's considerably bigger. It's twice the size of the other one, but it's running BC5. And besides removing the blue color, it does a lot better job at the switches between red and green, because BC compression is quite weak when it comes to gradients between red and green, and a normal map is nothing but gradients between red and green and blue. So it does a couple of special tricks. It also recalculates to, I believe, -1 to 1, so the range is different and so on. So it's very important that normal maps are configured as BC5, normal map compression there. Now, the reason we want to compress things is because we have limited memory and bandwidth. There's a couple of other limitations as well. Shaders have a maximum number of texture samplers per shader. Now, that doesn't really have anything to do with compression itself. Whether the texture is compressed or not compressed, it doesn't change the limit a shader has. But it's still important to note that a shader or a material has a maximum number of textures it can look up per material. So there's a limit there. Texture resolution affects the memory and the bandwidth, okay, but it doesn't affect rendering performance, or rarely. So if you have a problem where there's too many textures, the textures are too large, you're running out of bandwidth or whatever is in that direction, then that's going to result in lag and freezes. So you're going to get frame drops, you're going to get sudden freezes where the screen freezes up for a second and then continues. Anything in that direction, that's usually shows you that there's a memory or bandwidth problem. It doesn't bring your frame rate down consistently. That's not what happens with these things. Now there's another thing we have to do, and that's our MIP maps. Now MIP maps is a copy of a texture at 1/4 of the size. And again, and again, and again, multiple times, more times than we're showing here, right? So this is the original image, and this is 1/4 of that. And that is 1/4 of that, and that is 1/4 of that, and so on. There's a couple more steps down here. These MIP maps are actually saved within the DDS file itself, within the texture itself. So you go back to Unreal, you can see that here too. As it says here, lot bias. And you can see if you change this number, 0 is the default size. You can see at the top, it's imported as 2048 and it's displayed as 2048. I set it to 1, it's displayed as 1024, displayed as 512, and so on. So you can see these are the MIP maps. At 6464 is obviously very small and blurry. So each texture remembers a copy of itself and a copy of that one and so on. It remembers the numbers of copies that are all embedded within that same texture. Each one smaller than the previous step. And the reason we're doing that, and all of this is generated by itself, by the way, you don't have to set this up manually. The reason we're doing that is because without MIP maps, it will become very noisy. So on the left side, you see with MIPs, on the right, it's without. And what's actually happening here is that the MIP maps work like this. Based on the distance, it switches MIPs. It's still the same texture, but it actually switches MIPs. So it actually uses a blurrier version, a lower resolution version of itself at a different distance. If you want to call it like that, it actually uses a different texture at another distance. So up close to the camera, if you see here the non-colored area all the way in the front, This is not an actual view, by the way. This has been a photoshopped approximation, so it's not accurate, but it gets the idea across. Up front, you have the original 2048 stone texture. But then, if it starts going a little bit further away, the red area would use the 1024 version of that same texture. And it blends between the two, so you don't see the transition. And then over here, the green part, that would be the 512 by 512 version of that same stone texture. Then we go to 256, then we go to 128, and then we go to 64, and there's a couple more steps underneath. So it switches to lower versions of the texture, and that results in that it smoothens out. It literally is blurrier in the distance because it's using a low resolution texture. Besides the visual benefit of this, the fact that it looks less noisy, we'll also have to do this because we're dealing with texture streaming. And texture streaming is the process of determining when the engine needs which texture and at which MIP and at what point in time. Because you don't want to load all the textures you might ever need. You will run out of bandwidth and you will run out of memory, and it's going to give you a very long loading screens. So you don't want to do that. You only want to load what you needed when you needed at that point in time, at that location, with that camera angle. Right? Because you don't know where the camera is going to be. It's real time. You don't know if the camera is going to walk into if the player or the viewer or whatever is controlling the camera is going to take it into a train station. So you don't know if you have to load the train station textures right at the very start of the application or the game or later on. So for that reason, there is texture streaming. So in order to facilitate texture streaming and mipmaps as well, we have to have textures that are a power of 2. This is where the power of 2 requirement comes from. So any size you see displayed here is acceptable. So 1 by 1, 2 by 2, 4 by 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, and 8192 are all acceptable. Any combination of these numbers is acceptable. You could do a 16 by 4096 texture and it's fine. But it has to be one of these numbers. It has to be a power of 2. If you do not have a texture that's a power of 2, it will import and it will work, but it will not do mipmaps and it will not stream correctly. Okay? And sometimes that's even a good thing. Sometimes you actually want a texture that doesn't have mipmaps. And which textures don't need mipmaps? Well, textures that are never seen from far away. Because it's any texture that is seen from different distances, those need mipmaps. But for example, interface textures, a menu, is never seen from far away. A menu is always at the very front of the renderer. It's on top of everything. So when you're dealing with interface elements, you can make those any resolution, any size you want, and they don't need mipmaps. But any other texture will have to adhere to this rule for this reason. And that wraps up this part. We'll continue by taking a look at shaders in the next video.